My channel, Campus with Salvation, and I'm Salvation from University of Education, Winneba, and I'm here to present to you on the topic measurements in science. Okay, but before we talk about measurements, let's look at the definition of measurement. Measurement is the comparison of an unknown quantity with some fixed quantity of the same kind. I know some years ago there wasn't a standard unit for measurements. So what happened was that there was cheats in our economy, and since then we have a standard unit for all measurements in the world. That's the SI unit, which is System International de Units. That's the full meaning of SI units. Yeah. So we want to know some quantities with their SI units for now, and later we proceed on how to calculate for them. Okay, there are two kinds of SI. There are two kinds of quantities. We have the derived quantities and the basic quantities, or the fundamental quantities. There are 7 basic quantities, and they are: we have length, time, mass, current, temperature, luminous intensity, and the last one, amount of substance, or the mole substance. Okay, so let's deal with the basic quantities first, and before then we go to the derived quantities. And the derived quantities can be obtained from combining 2 or more basic quantities. So we have length, which is measured in meters. That's the unit for length. We have time, which is measured in seconds. Mass is measured in kilograms, or grams, but I will tell you as and when we use both kilograms and the grams. Okay, current is measured in ampere. Temperature is measured in Kelvin. That's someone's name. He was the one who discovered everything about temperature, so the SI unit was named after him. Luminous intensity is measured in candela. It also shows someone's name. Amount of substance is measured in mole. Okay, so as we proceed, we will learn how to solve for length, time, in terms any questions is being given. Okay, so as we've gotten to know the 7 basic quantities, let's come to the derived quantities. There are several derived quantities which we can even solve for them. But before then, we will just talk about few one. But as time goes on, we'll be solving more questions on them. And some derived quantities are, okay, let's mention few of them so that we just tackle with it. We have force, we have work or energy, we have power. Yes, these are derived quantities. They are many. We have electricity, we have volume, we have density, we have what we call velocity, acceleration. There are many, but we will tackle few of these. And these quantities has its own formulas and its own SI units we use to measure them. So after calculating the value for force, work, power, electricity, volume, Each has its own SI units we use to attach it. Okay, force has an SI unit of newtons, which has a symbol of capital N. Work or energy has an SI unit of joules, which has a symbol of J, capital J. Power is measured in watts with a symbol of big W, and electricity is measured in coulomb. Volume is measured in meter cube or centimeter cube. So after calculating for a quantity of volume, you must attach the figure with cm cube or meters cube. We have density, which has an SI unit of kilograms per meter cube or grams per cm cube. Yeah, when you calculate it in kilograms, the meters or the SI units in the volume must be in meter cube, but when you calculate it in grams, the volume unit must be in cm cube. It shouldn't be meter cube. So that's how we go about it. You have velocity, which is also measured in meters per seconds or meters like this. You can write it in this form or in this form. They are all the same. Acceleration has an SI unit of meters per second squared. Yeah, or meters per second squared. This and this are the same. So any one of your choice you can use. Okay, let's proceed on the various formulas for calculating each of these quantities. So let's proceed on the various formulas for calculating force, and we can derive the unit from it so that you understand where we get each of the SI units I just used. Okay, let's take force. The formula for finding force is F is equal to M, where M is mass and A is acceleration. Yeah. So mass is also measured in meters. Mass is measured in kilograms or grams. So that's the formula for finding force. We also have energy or work. And let us proceed on the formula for finding work or energy. W is equal to distance. That's for work. This force, distance times force. So before work could be done, force must be applied, and when the force applied, a distance must be covered. So you can try to pull or push a wall, irrespective of the energy you are going to use, and the wall still remain the same. The work done is zero because no distance has been discovered. So definitely the work done will be zero. So before a work must be done, you need to multiply distance with force, because you need to apply force, then you just proceed on. So let's look at the formula for finding power. Power has a formula of power. Power is equal to, so P is equal to work done over time. Yeah, this is the formula for finding power. Work done over time. So before you can solve for power, you need to get the work that has been done and you divide it by time, which is measured in seconds. So as you proceed, you solve more questions on how we go about all these. Okay, so we have something like electricity, which is also measured in current. So electricity is equal to current. Electricity measured in current times time. Yeah. So we can calculate for electricity, but we need to know our current, which is measured in ampere, and time is measured in seconds. Yeah, and AS, so multiplying the ampere by seconds is equal to coulomb. So after calculating electricity, we leave this SI with the figure. So A times S, that's ampere, times second, that's time, will give you is equal to coulomb. Instead of writing AS complicated form, you can just write coulomb as your SI units. So we have several of them. Volume, density. So formula for finding density is equal to, you need to get your mass over volume. So before you calculate for density of some objects or anything, you need to get the mass of that object and its volume. And mass is measured in kilograms per volume is measured in meter cube. So as the formula goes, so formula for density is mass over volume, and the SI unit must be kilograms per meter cube, or you can just measure it in grams depending on the quantity, grams per meter cube. So we have several of them. So let's tackle other ones and see how we can solve more questions about it. But let me tell you something here. When you are calculating the distance from maybe Kumasi to Accra, you don't need to calculate that distance with meters or like with grams. You need to calculate it with kilometers, because from Kumasi to Accra is very large quantity, so you need to calculate it with kilometers, which is in thousands. So take note of it. Each quantity has its own way of calculating it. So as we proceed, we will get to know how to solve questions on these various quantities, and this may be in our next lessons, so that we proceed on. So for now, we can end here. I know for now that each and every one of you can relate with how to solve force or know the formulas for finding force, work done or energy, power, electricity, volume, current, and those stuff. Yeah, I know, because and as I started, I told we have two main kinds of quantities. We have the derived quantities and the basic quantities. So I'm very sure at the end of this lesson, you can all differentiate what basic quantities are and derived quantities are. I said derived quantities can be obtained from the combination of two or more of the basic quantities. So as you can see, let's look at example for power. We combine work done over time before we were able to obtain power. So you can even see the formulas and it relates with. Let's look at something like amount of substance, which is mole. So let's write the formula for finding mole. Mole is equal to mass over molar mass. So mass is here. Mass is part of the basic quantity. So with the combination of mass and the molar mass, you're able to get mole. So that's how it is. Derived quantities can be obtained from combining these two basic quantities of it. So as I said, we will continue with these measurements and know how to solve questions. So in next episode, we are going to solve several questions on the following quantities, and from there we proceed on to another topic, which may be either chemistry or under biology. So let's watch out and stay tuned with this channel, and don't forget to subscribe and share. You can also like for others to get the content and watch. But let me tell you something here. In case you don't understand certain questions in terms of science and mathematics, you can comment under the comment section so that we can help you. So you just comment it with the kind of topic you don't understand or you are finding it difficult to relate to, so that in our next episode we can at least treat that topics. And besides, we'll be solving more of past questions in terms of mathematics and science. So stay tuned and focus. Just subscribe to the channel and always flash it through it, and we are going to give you a correct content which will help your education and establish well or excel in your coming exams, either WASSCE, SSCE or any terminal exam. So stay tuned. Love you all and have a blessed day. The name still remains the same, Salvation, and the channel is Campus with Salvation. I'm Salvation from the University of Education, Winnipeg. Love you all. Bye bye.